All right, we're going to begin lesson 3.7 today, and this is on parallel lines and transversals. The idea we're going to work with primarily today is we're going to identify the different angles created and the relationships between those angles when we have transversals or even parallel lines with transversals. Okay, a lot of key terms and ideas here that we're going to use for the rest of the year. Okay, if two lines don't intersect, then they're either parallel or skew. We need to know the difference. Okay, parallel lines are lines that are in the same plane that don't intersect. All right. So, for instance, if this was my drawing, now they're in the same plane. The plane is the surface of the screen, if you will. JK and LM are parallel. See that triangle that they wrote in here? This triangle that matches that triangle, that indicates parallel. So JK is parallel to LM. JL is obviously intersecting both of those. So JL is not parallel to either one. So it's JK parallel to LM. Okay, skew lines. Skew lines also are lines that don't intersect, but for these guys, they're not in the same plane. So take a look at this. If you can imagine that plane A and B are parallel to each other, then there's a line that exists in plane B and one that exists in plane A. They're not parallel to each other, but they don't intersect each other either. So those are skew lines. Not going to do a whole lot with that this year, but it's important we understand. And parallel planes are planes that don't intersect, and in parallel planes, which is like this example now down here, these planes are flat surfaces that extend in with all directions are an equal distance apart, so they'll never intersect. Lines that are in these planes are typically going to be skew. Okay, so there's a look at the different ways we can look at parallel and skew. All right, identify parallel and skew relationships. This is a pretty common example. They give you a cube and ask you to name a couple things. For example, name all lines that are skew to BC. So here's BC. We're asking for all lines that are skew to it. So not parallel to it. AD is parallel to it. FE is parallel to it. And GH is parallel to BC. CD intersects it. AB intersects it. So the ones that are skew to it would be AF. So imagine BC is this line and it goes on forever this direction. AF's going up and down. They're never going to intersect. DE does the same thing. FG, again, FG's this kind of on this path right here. It's going to go on and on forever in this direction. And this one's up here going this way. Those are skew as well as HE. What are lines are parallel to EH? Okay, so over here's EH. So what lines are parallel to it? Well, AB is parallel to it, CD is parallel to it, and GF, the edges that are parallel to EH. And then name all planes parallel to DCH. When we name a plane, we just need 3 points that are not in the same line. So DCH is really showing you this side of the cube. So the other face that's parallel to it is the one that's across from it. So we can call that ABG, we can call it AFG or AGF. We can name it a bunch of different ways. We basically need three of these four letters to represent that plane. Okay. Okay. The idea of now of transversals. So transversals are basically a line that intersects two or more other lines in a plane. So in this diagram, T is a transversal. It's intersecting line Q and line R. Okay. And also notice when you get a transversal through lines, 8 angles are created, 4 angles in the first intersection and another 4 angles in the second intersection. And now we're going to classify and look at these angles. One way we're going to classify them is on interior and exterior angles. So interior angles are the angles that are between the two lines being intersected by the transversal. So they're on the inside. So the interior angles in this case are 3, 4, 5, and 6. Exterior angles are the angles that are outside, on the outside of the intersection of the two lines of the transversal. So they would be the points 1, 2, 7, and 8. So we'll look at interior and we'll look at exterior points when we have a transversal. Okay. We're also going to talk about some special angle pair relationships. Okay. One thing that we'll talk about is consecutive interior angles. Okay. Consecutive. So first of all, we know interior 3, 4, 5, and 6. Consecutive interior means they're on the same side of the transversal together. Okay. So consecutive would be 3 and 6 and 4 and 5. Those are consecutive interiors. And there's a reason we talk about these, but right now we just need to be able to pick them out. So 3 and 6 are consecutive because they're on the interior and they're on the same side of the transversal. 4 and 5 for the same reason. Okay. Alternate interior angles. Okay. So alternate interior angles are non-adjacent interior angles that are on the opposite side of the transversal. So alternate interiors, we're looking at interior angles. They're on the opposite side of transversal. So 4 and 6 are alternate interiors. 3 and 5 are alternate interiors. Okay, alternate exteriors. Well, now go to your exterior angles 1, 2, 7, and 8. Alternate means opposite sides of the transversal. So our alternate exteriors would be 2 and 8 and 1 and 7. Okay, and then the last thing we talk about corresponding angles. So corresponding angles are angles that are in the same position of the intersection of the two. So, for example, 1 and 5 are the upper left hand angle. 2 and 6 are the upper right hand angle from the intersections. 3 and 7 are in the same spot. They're the lower right hand angle. 4 and 8 are the lower left hand angle. So those are the corresponding angles. They're in the same position of the intersection of the four angles. Okay. So consecutive interiors, alternate exteriors, corresponding angles. We have to know all of that. Have to be able to identify it. Okay. So in this diagram, name a pair of alternate interiors, a pair of corresponding, and a pair of alternate exteriors. So there's several choices. So alternate interiors, first of all, let's identify, in this case, what are the interior and exterior angles. All right, because the transversal now is running this way through these two lines. The interior will be right here. 3, 4, 5, and 6 are between the lines. 1, 2, 7, and 8 are outside of the intersection. So those are your interior, exterior. Alternate interior, opposite side of the transversal. So you can pick 4 and 5, or you could pick 3 and 6. That's a pair. 4 and 5 are a pair. 3 and 6 are a pair. Corresponding angles, that means they're in the same position of the intersection. So 1 and 5 are in the same bottom left. 2 and 6 are the top left. 4 and 8 are the top right. 3 and 7 are the bottom left. So you get four pairs there to choose from. And then alternate exteriors, remember exterior on the outside. So 1, 2, 7, and 8 are the outside angles. 2 and 7 are on opposite sides of the transversal. 1 and 8 are on opposite sides of the transversal. Now moving over here, because the lines have changed a little bit, our transversals now running this way, up and down. We got to identify though interior, exterior first. So interior are the four angles that are between the lines that are being intersected by the transversal. So 2, 3, 6, and 7 are interiors. 1, 5, 4, and 8 are the exteriors. So name a pair of alternate interiors. Well, you can either choose 2 and 7 or 3 and 6. Name a pair of corresponding. Well, there's four different choices. You got 1 and 3, 5 and 7, 2 and 4, 6 and 8. And then alternate exteriors, right? Exteriors on the outside of the transversal, 1 and 8, 4 and 5. Okay. So that's how you identify them, and make sure that you put them in pairs according to what they're being asked for. Okay, now when we take a pair of parallel lines and cut it by transversal, then we get a unique situation. All right. So when two parallel lines, so notice again that little triangle right there and there. So that means this line is parallel to this line. Here's my transversal coming through. So we got several different relationships or special relationships that occur. First thing we talk about is a corresponding angles theorem. And what this theorem says is that the angles that correspond are congruent. So these four angles are the exact same as these four angles. So 1 and 3 are the same. They correspond upper left, upper left. 2 and 4 are upper right. They are the same angle. 7 and 5 are the same angle. 8 and 6 are the same angle. Because the lines are parallel, when this transversal comes through, it cuts the same four angles here as it cuts here. All right. And that's what we're working off of. Alternate interior angles, they're going to be congruent. So I know 2 and 6 are going to be the same angle, and I know 7 and 3 are going to be the same angle. Alternate exterior angles are going to be congruent. So I know 1 and 5 are going to have the same angle measure. 8 and 4 are going to have the same angle measure. Consecutive interiors, same side of the interior here, these two are going to be supplementary. And you'll see this in a minute, but 2 and 3 are going to add up to 180. 7 and 6 are going to add up to 180. All right, so there's a little difference there. All right, but we corresponding angles are congruent, alternate interior angles are congruent, alternate exterior angles are congruent, and consecutive interiors are supplementary. Okay, now we start to put that to use. First example, let's say that angle 8 is 108 degrees. They're asking us to find 1 and 3. The way I do this is I kind of solve the whole thing. All right, so for example, I know 8, they tell me is 108 degrees. Well, 8 and 6 are vertical, so 6 is 108 degrees. 8 and 7 are a linear pair. They're going to add up to 180. So I know I take 72 plus 108, I get 180. So 7's got to be 72. And then 5 and 7 are vertical, so I know 572. I also know because the lines are parallel, it tells me up here that these four angles and these four angles are exactly the same. So I can just transpose these numbers up here. So now I solved it. I found every angle. Now angle 1, just go find it. Angle 1 is 72. Angle 3, it's 72 also. Okay, for a lot of reasons, but that's the way I usually do it. Okay, another example. 6 is 44. Find 1 and 4. So 6 is 44 right here. So I know 8's 44. I know 6 and 5 are a linear pair. They're going to add up to 180. So that's actually 6 and 7 too. That's 136. And then 7 and 5 are vertical. So that's 136. And then these four angles are the exact same as these four. So I can transpose those angles down here. And now I go look. Angle 1. All right. Angle 1's to 136. Angle 4. Got it. 44. Easy way to do it. Okay. All right, two parallel lines, G and H. So we know these are parallel, are cut by a transversal F. So here's my transversal. Suppose angle 1 is 50 degrees. Okay. Now they're going to want us to fill in some information here. So let's go ahead and do that. We see angle 1 and angle 2 are what? Well, angle 1 and angle 2 are what to each other? Hopefully you see they're vertical. Therefore, angle 1 and angle 2 are congruent or equal in measure. So if the measure of angle 2 has got to be the same as 1, which we know is 50. So the measure of angle 2 is 50 degrees. Okay. We can see that 2 and 3 are what? How are 2 and 3 related? Well, they're in the same spot, upper left, upper left. That means they are corresponding angles. Since G is parallel to H, that means 2 and 3 they're going to be congruent because corresponding angles are congruent. So the measure of angle 3 has got to be the same as the measure of angle 2. So it's got to be 50. Therefore, 1 and 3 are going to be what? Well, we know 1 is 50. We know 3 is 50. So they're congruent. So we now know 1 and 3 are congruent. They are what to each other? Well, those are alternate interiors. The relationship between 1 and 3 is an example of the following rule. When parallel lines are cut by a transversal, we know that alternate interior angles are congruent. Okay, you're going to have some like this tonight, just taking you through it. Let's go through another one here. Two lines, S and T, are cut by a transversal D. So here's S, here's T, here's transversal D. Angle 1 is 55 degrees. Okay, so we'll just go through the same process. So 1 and 2 are what to each other? Well, 1 and 2 are vertical, and therefore 1 and 2 are congruent or equal. So the measure of angle 2's got to be the same as 1. So 1's 55, so 2's 55. Okay, we can see 2 and 3 are what to each other? Well, those are corresponding angles again. Bottom left, corresponding. Since S is parallel to T, 2 and 3 are going to be congruent. Corresponding angles are congruent if the lines are parallel. So now we know the measure of angle 3 has got to be 55 degrees because 2 and 3 are the same. Therefore, 1 and 3 are going to be congruent. We know 1's 55, 2's 55, 3's 55. So 1 and 3 are congruent. We can also see 1 and 3 are what? Well, how are these two related from our terminology? They are alternate exterior angles. So we know they're congruent. We know they're alternate exteriors. So the relationship between 1 and 3 is an example of what? Well, when parallel lines are cut by a transversal, alternate exterior angles are congruent. We just proved it. Okay, it's kind of a little proof there. Okay, so that's where we're going to begin with parallel lines and transversals. A lot of terminology there. Hopefully you wrote down some notes and you're ready to use those notes to help you with homework. The homework's on Alex, and I'll let you get